Radiologic Technologist Exam Questions and Answers. Question 1. A thin metallic sheet, brass, copper, aluminum, etc., placed at the source to reduce the effects of softer radiation is known as Option A. An intensifying screen. Option B. A filter. Option C. An electron inducer. Option D. A focusing cup. The correct answer is Option B. A filter. A thin metallic sheet placed at the source to reduce the effects of softer radiation is known as a filter. Filters are commonly used in various fields, including photography and radiology, to selectively allow certain wavelengths or types of radiation to pass through while blocking others. In this case, the filter is used to reduce the effects of softer radiation, meaning it can selectively block or attenuate low-energy radiation, allowing only higher-energy radiation to pass through. This helps to improve image quality and reduce unwanted effects caused by softer radiation. Question 2. What is sometimes used to change the alternating current from the high-voltage transformer to direct current for the purpose of increasing the X-ray machine output? Option A. Rectifier. Option B. Cathode X-ray tubes. Option C. Gas X-ray tube. Option D. Vacuum X-ray tube. The correct answer is Option A. Rectifier. A rectifier is sometimes used to change the alternating current from the high-voltage transformer to direct current for the purpose of increasing the X-ray machine output. A rectifier is an electrical device that converts alternating current, AC, to direct current, DC, allowing the X-ray machine to operate with a steady flow of current in one direction. This conversion is necessary to ensure a consistent and reliable output from the X-ray machine, as direct current is required for its operation. Question 3. Excessive exposure of the film to light prior to the development of the film will most likely result in Option A. A foggy film. Option B. Poor definition. Option C. Streaks. Option D. Yellow stain. The correct answer is Option B. Poor definition. Excessive exposure of the film to light prior to development can cause the film to become overexposed, resulting in a foggy appearance. This occurs because the excessive light exposure causes the film to be exposed to more light than it can handle, causing the image to become washed out and lacking in detail. This is different from poor definition, streaks, or a yellow stain, which are caused by other factors such as improper development or chemical contamination. Question 4. The extent to which X-rays can be successfully utilized in non-destructive testing is largely dependent upon Option A. Their intensity of the X-rays generated. Option B. Their wavelengths. Option C. The dimensions of the area from which they are emitted. Option D. The duration of their emission. The correct answer is Option A. Their intensity of the X-rays generated. The extent to which X-rays can be successfully utilized in non-destructive testing is dependent on multiple factors. The intensity of the X-rays generated is important as it determines how well the X-rays can penetrate and detect defects in the material being tested. The wavelengths of the X-rays also play a role, as different wavelengths are better suited for different types of materials. The dimensions of the area from which the X-rays are emitted are significant because they determine the coverage and resolution of the imaging. Lastly, the duration of the X-ray emission affects the exposure time and the ability to capture clear and accurate images. Therefore, all of the above factors are important in determining the successful utilization of X-rays in non-destructive testing. Question 5. Which of the following is an advantage of a fluoroscopic system when compared to a radiographic system? Option A. Screens to not absorb scattered radiation so the image density is enhanced. Option B. Live imaged presentation for immediate viewing. Option C. Screen systems exhibit superior sensitivity and resolution to films. Option D. The equipment is normally not portable. The correct answer is Option B. Live imaged presentation for immediate viewing. A fluoroscopic system offers the advantage of live imaged presentation for immediate viewing. This means that the images can be seen in real time, allowing for immediate analysis and diagnosis. This is particularly useful in procedures that require real-time monitoring, such as surgeries or interventions. Unlike a radiographic system, where the images need to be developed and processed before they can be viewed, a fluoroscopic system provides instant visualization, saving time and allowing for immediate decision-making. Question 6. If the SNTTC 1A guidelines are to be followed, the LVL3 technician should have the knowledge of other commonly used methods of NDT even though CERT is needed in only the radiographic area. Option A, true. Option B, false. The correct answer is option true. According to the SNTTC 1A guidelines, even though certification is only required in the radiographic area, a Level 3 technician should have knowledge of other commonly used methods of non-destructive testing, NDT. This implies that the technician should be familiar with other NDT techniques in addition to radiographic testing. Therefore, the statement / if the SNTTC 1A guidelines are to be followed, the LVL3 technician should have the knowledge of other commonly used methods of NDT even though CERT is needed in only the radiographic area / is true. Question 7. Wavelength is usually described as the distance between two angstrom units. Option A, true. Option B, false. The correct answer is option false. L2 wavelength is typically defined as the distance between two angstrom units. Question 8. Angstrom units are used to measure the wavelength of X and gamma rays. Option A, true. Option B, false. The correct answer is option true. L2 angstrom units are indeed used to measure the wavelength of X and gamma rays. The L2 angstrom unit is a unit of length commonly used in scientific fields, particularly in spectroscopy, to measure extremely small wavelengths. X and gamma rays have very short wavelengths, and using L2 angstrom units allows for precise measurements and comparisons of these wavelengths. Therefore, the statement is true. Question 9. The metal that forms the image on an X-ray film is Option A, tin. Option B, silver. Option C, tungsten. Option D, iron. The correct answer is option B, silver. Silver is the metal that forms the image on an X-ray film. X-ray films work based on the principle that different materials absorb X-rays to varying degrees, creating an image. Silver is used in X-ray films because it is highly sensitive to X-rays and can produce a clear and detailed image. It is coated with a layer of gelatin that contains silver halide crystals. When X-rays pass through the body and strike the film, they interact with the silver halide crystals, causing them to darken and form an image. Question 10. In X radiography, the ability to penetrate the test object is governed by Option A, source to film distance. Option B, time. Option C, kilovoltage. Option D, milliamperage. The correct answer is option C, kilovoltage. In X radiography, the ability to penetrate the test object is governed by kilovoltage. Kilovoltage refers to the energy level of the X-ray beam. Higher kilovoltage results in greater penetration of the X-rays through the object being tested. This is because higher kilovoltage increases the energy of the X-ray photons, allowing them to pass through denser materials. Therefore, kilovoltage plays a crucial role in determining the quality and clarity of the X-ray image obtained during radiography. Question 11. The two most common reasons for excessively high-density radiographs are Option A, insufficient washing and overdevelopment. Option B, contaminated fixer and insufficient washing. Option C, overexposure and contaminated fixer. Option D, overexposure and overdevelopment. The correct answer is option D, overexposure and overdevelopment. Overexposure refers to the excessive amount of radiation that the film receives during the exposure process. This can result in a dark and dense radiograph. On the other hand, overdevelopment refers to the excessive amount of time that the film spends in the developer solution. This can cause the image to become even darker and denser. Therefore, the combination of overexposure and overdevelopment can lead to excessively high-density radiographs. Question 12. An intensifying fluorescent screen will Option A, transform X-ray energy into visible or ultraviolet light to which a photographic emulsion is sensitive. Option B, result in reticulation. Option C, decrease the graininess of the image when using gamma rays. Option D, increase the definition in a radiograph. The correct answer is option A, transform X-ray energy into visible or ultraviolet light to which a photographic emulsion is sensitive. An intensifying fluorescent screen will transform X-ray energy into visible or ultraviolet light to which a photographic emulsion is sensitive. This means that when X-rays pass through the screen, they are converted into light that can be captured by a photographic emulsion, allowing for the creation of a radiograph. This transformation of X-ray energy into visible or ultraviolet light is the purpose of using an intensifying fluorescent screen in radiography. Question 13. The primary parts of an atom are: Option A, proton, neutrino, electron. Option B, proton, electron, gamma ray. Option C, photon, electron, neutron. Option D, proton, electron, neutron. The correct answer is option A, proton, neutrino, electron. The primary parts of an atom are proton, electron, and neutron. Protons are positively charged particles found in the nucleus of an atom, while electrons are negatively charged particles that orbit around the nucleus. Neutrons are neutral particles also found in the nucleus. These three components together make up the structure of an atom. Question 14. The 1980 edition of SNT-TC1A permits the employer to waive an examination for LVL3 personnel provided that documentation is on file showing the technician's qualifications. Option A, true. Option B, false. The correct answer is option true. The 1980 edition of SNT-TC1A allows the employer to exempt Level 3 personnel from taking an examination if they have proper documentation proving their qualifications. This means that if the technician's qualifications are already established and documented, the employer can waive the examination requirement for Level 3 personnel. Therefore, the statement is true. Question 15. If the discontinuity in an object was less dense than the specimen, then it would appear on the film as a dark spot. Option A, true. Option B, false. The correct answer is option false. If the discontinuity in an object is less dense than the specimen, it would appear on the film as a dark spot. This is because X-rays are absorbed more by denser materials, causing them to appear lighter on the film. Therefore, if the discontinuity is less dense, it would allow more X-rays to pass through, resulting in a darker spot on the film. Question 16. In order to increase the intensity of X radiation, option A, the tube current should be increased. Option B, the tube current should be decreased. Option C, the test specimen should be moved further from the film. Option D, a lower kilovoltage should be applied to the tube. The correct answer is option A, the tube current should be increased. To increase the intensity of X radiation, the tube current should be increased. Tube current refers to the flow of electrons in the X-ray tube. By increasing the tube current, more electrons are generated, resulting in a higher intensity of X radiation being produced. This can be beneficial in situations where a higher level of X radiation is needed for imaging purposes, such as in medical diagnostics or industrial inspections. Question 17. In order to produce X-rays, electrons are accelerated to a high velocity by an electrical field and then suddenly stopped by a collision with a solid body. This body is called: Option A, cathode. Option B, filament. Option C, target. Option D, generator. The correct answer is option C, target. The body that is responsible for stopping the accelerated electrons and producing X-rays is called the target. When the high-velocity electrons collide with the target, they release energy in the form of X-rays. The target is typically made of a dense material, such as tungsten, that can withstand the impact of the electrons and efficiently convert their kinetic energy into X-rays. The target plays a crucial role in the generation of X-rays in various applications, including medical imaging and industrial inspections. Question 18. The term used to describe the loss of excess energy by the nucleus of radioactive atoms is called: Option A, decay, disintegration. Option B, ionization. Option C, scintillation. Option D, activation. The correct answer is option A, decay, disintegration. The correct answer is \decay, disintegration, \. Decay or disintegration refers to the process in which the nucleus of a radioactive atom loses excess energy by emitting radiation. This process occurs spontaneously and can result in the transformation of one element into another. Ionization, on the other hand, refers to the process of adding or removing electrons from an atom, while scintillation refers to the emission of light by a substance when it absorbs radiation. Activation refers to the process of making a material radioactive by bombarding it with particles. Question 19. L5 The Bremsstrahlung process involves the production of ion pairs when one electron collides with another. Option A, true. Option B, false. The correct answer is option true. The statement is true because the Bremsstrahlung process refers to the production of ion pairs when an electron collides with another. This process occurs when the electron is accelerated or decelerated by a strong electric field, causing it to emit electromagnetic radiation and create ion pairs. Therefore, the statement accurately describes the Bremsstrahlung process. Question 20. Scattered radiation caused by any material, such as a wall or floor, tabletop, or cassette that is located at the back of the film, is known as Option A, primary scattering. Option B, undercut. Option C, reflected scattering. Option D, backscattered radiation. The correct answer is option D, backscattered radiation. Backscattered radiation refers to the scattered radiation that occurs when X-rays pass through a material and are redirected in the opposite direction, back towards the source. This can happen when X-rays encounter objects such as walls, floors, tabletops, or cassettes located behind the film. The term backscattered indicates that the radiation has been scattered back in the direction it came from. Therefore, the correct answer is backscattered radiation. Question 21. Lead screens increase photographic action. Option A, true. Option B, false. The correct answer is option true. L14 lead screens increase photographic action. This statement implies that the presence of L14 lead screens enhances the effectiveness or performance of photography. Therefore, the answer /true/ indicates that the statement is correct and L14 lead screens do indeed increase photographic action. Question 22. X-ray heat is generated by Option A, the current passing through the filament, cathode. Option B, the distance from the cathode to the anode. Option C, the type of material used in the target. Option D, the voltage and waveform applied to the X-ray tube. The correct answer is option A, the current passing through the filament, cathode. X-ray heat is generated by the current passing through the filament, cathode, because the filament is heated up by the current, causing it to emit electrons. These electrons are then accelerated towards the anode, creating X-rays through the process of Bremsstrahlung radiation. The heat generated by the current passing through the filament is essential in producing the necessary energy for the X-ray production. The other factors mentioned, such as the distance from the cathode to the anode, the type of material used in the target, and the voltage and waveform applied to the X-ray tube, may affect the intensity and quality of the X-rays produced, but they do not directly generate the X-ray heat. Question 23. X-rays have a higher frequency than visible light and therefore have a higher velocity. Option A, true. Option B, false. The correct answer is option false. Although visible light, X and gamma rays both travel at the velocity of light, 186,000 mph, X and gamma rays have a higher frequency than visible light. Question 24. Inherent unsharpness causes poor contrast and definition but can be eliminated by using a longer source-to-film distance. Option A, true. Option B, false. The correct answer is option true. Inherent unsharpness refers to the blurring of images caused by factors such as the size of the X-ray focal spot and the motion of the patient. This blurring can result in poor contrast and definition in the X-ray image. However, by increasing the source-to-film distance, the blurring effect can be reduced, leading to improved contrast and definition. Therefore, it is true that using a longer source-to-film distance can eliminate the effects of inherent unsharpness. Question 25. Radiographic sensitivity, in the context of the minimum detectable flaw size, depends on Option A, the graininess of the film. Option B, the unsharpness of the flawed image in the film. Option C, the contrast of the flawed image in the film. Option D, all three of the above. The correct answer is option A, the graininess of the film. Radiographic sensitivity, in the context of the minimum detectable flaw size, depends on the graininess of the film, the unsharpness of the flawed image in the film, and the contrast of the flawed image in the film. The graininess of the film refers to the size and distribution of the silver grains within the film, which can affect the clarity of the image. The unsharpness of the flawed image refers to any blurring or lack of sharpness in the image, which can make it more difficult to detect flaws. The contrast of the flawed image refers to the difference in brightness between the flaw and the surrounding area, which can affect the visibility of the flaw. Therefore, All three factors play a role in determining radiographic sensitivity. Question 26. The exposure of personnel to X and gamma radiation is measured or monitored by means of Option A. Film badges. Option B. Dosimeters. Option C. Radiation exposure survey meters. Option D. All of the above. The correct answer is Option A. Film badges. All of the options mentioned, film badges, dosimeters, and radiation exposure survey meters, are used to measure or monitor the exposure of personnel to X and gamma radiation. Film badges are small devices containing photographic film that darken when exposed to radiation. Dosimeters are instruments that measure the amount of radiation received over time, and radiation exposure survey meters are handheld devices used to measure radiation levels in an area. Therefore, all of these options are valid methods for monitoring personnel exposure to X and gamma radiation. Question 27. The lead symbol \B/ is attached to the back of the film holder to determine Option A. Sensitivity. Option B. Whether excessive backscatter is present. Option C. Radiographic contrast. Option D. Density. The correct answer is Option B. Whether excessive backscatter is present. The lead symbol \B/ is attached to the back of the film holder to determine whether excessive backscatter is present. Backscatter refers to the radiation that is scattered back towards the film after passing through the object being radiographed. By attaching the lead symbol \B/ to the back of the film holder, any excessive backscatter can be identified and evaluated. This helps in assessing the quality of the radiographic image and ensuring that the desired level of clarity and detail is achieved. Question 28. During manual film processing, the purpose of the stop bath is to Option A. Change the exposed silver salts to black metallic silver. Option B. Neutralize the developer and stop the developing process. Option C. Eliminate most water spot and streaks. Option D. Note of the above. The correct answer is Option A. Change the exposed silver salts to black metallic silver. The stop bath in manual film processing is used to neutralize the developer and halt the developing process. This is important because the developer is responsible for converting the exposed silver salts into black metallic silver, which forms the image on the film. By neutralizing the developer, the film is prevented from further developing, ensuring that the desired level of exposure is achieved. Question 29. L2 the latent image refers to an image on the radiograph that cannot be seen without the aid high-intensity viewer. Option A. True. Option B. False. The correct answer is Option True. The latent image refers to an image on the radiograph that is not visible to the naked eye and requires the use of a high-intensity viewer to be seen. This means that without the aid of a viewer, the image cannot be observed. Therefore, the statement \the latent image refers to an image on the radiograph that cannot be seen without the aid of a high-intensity viewer is true. Question 30. If large areas of the film are exposed to radiation, this will cause the developer to become exhausted faster. Option A. True. Option B. False. The correct answer is Option False. Developing solutions can become exhausted. Chemical depletion of developer is proportional to the number and density of films developed. Question 31. What is the difference between the densities of two areas of a radiograph called? Option A. Radiographic contrast. Option B. Subject contrast. Option C. Film contrast. Option D. Definition. The correct answer is Option A. Radiographic contrast. The correct answer is radiographic contrast. Radiographic contrast refers to the difference in densities between two areas on a radiograph. It is used to describe the distinguishability of different structures within the image. Subject contrast refers to the differences in X-ray attenuation properties of the subject being imaged. Film contrast refers to the differences in densities on the developed film. Question 32. As the kilovoltage applied to the X-ray tube is raised, Option A. X-rays of longer wavelength and more penetrating power are produced. Option B. X-rays of shorter wavelength and more penetrating power are produced. Option C. X-rays of shorter wavelength and less penetrating power are produced. Option D. X-rays of longer wavelength and less penetrating power are produced. The correct answer is Option A. X-rays of longer wavelength and more penetrating power are produced. When the kilovoltage applied to the X-ray tube is raised, the electrons gain more energy, resulting in a higher velocity when they strike the target. This increased energy causes the production of X-rays with shorter wavelengths. Shorter wavelength X-rays have higher frequencies and therefore more energy, making them more penetrating. Question 33. When the minute silver grains on which the X-ray film image has formed a group together in relatively large masses, they produce a visual impression called Option A, air bells. Option B, graininess. Option C, reticulation. Option D, a frilling. The correct answer is option B, graininess. Graininess refers to the visual impression created when the minute silver grains on the X-ray film image group together in relatively large masses. This can result in a textured appearance with visible grain-like patterns on the image. Question 34. The small area in the X-ray tube from where the radiation emanates is called the Option A, diaphragm. Option B, focal spot. Option C, focusing cup. Option D, cathode. The correct answer is option B, focal spot. The small area in the X-ray tube from where the radiation emanates is called the focal spot. This is the point where the X-ray beam is focused and emitted. The size of the focal spot determines the resolution of the X-ray image. A smaller focal spot leads to a sharper and more detailed image. The focal spot is typically made of a tungsten alloy, as it has a high melting point and can withstand the high heat generated during X-ray production. Question 35. Gamma and X radiation interact with matter and may be absorbed by Option A, photoelectric absorption. Option B, Compton scattering. Option C, pair production. Option D, all of the above. The correct answer is option A, photoelectric absorption. Gamma and X radiation interact with matter in different ways. Photoelectric absorption occurs when a photon is completely absorbed by an atom, causing the ejection of an electron. Compton scattering happens when a photon collides with an electron, transferring some of its energy and changing direction. Pair production occurs when a photon interacts with the nucleus, creating an electron-positron pair. All of these interactions are possible for gamma and X radiation, which means that they can be absorbed by any of these processes. Question 36. Movement, geometry, and screen contact are the factors that affect radiographic. Option A, contrast. Option B, gun sharpness. Option C, reticulation. Option D, density. The correct answer is option B, unsharpness. Unsharpness in radiography refers to the lack of sharpness or clarity in an image. It is affected by movement, geometry, and screen contact. Movement of the patient or the X-ray machine during exposure can cause blurring and result in unsharpness. The geometry of the X-ray beam and the positioning of the patient can also impact the sharpness of the image. Additionally, the contact between the X-ray film and the intensifying screens can affect the overall sharpness of the radiograph. Question 37. Any of the body tissues may be injured by excessive exposure to X or gamma rays, but particularly sensitive are Option A, blood. Option B, the lens of the eye. Option C, internal organs. Option D, all of the above. The correct answer is option A, blood. Excessive exposure to X or gamma rays can cause injury to any body tissue. However, certain tissues are particularly sensitive to these rays, including blood, the lens of the eye, and internal organs. Therefore, all of the above tissues can be injured by excessive exposure to X or gamma rays. Question 38. Fluoroscopy differs from radiography in that Option A, fluoroscopy uses a much lower kilovoltage than radiography. Option B, fluoroscopy is much more sensitive than radiography. Option C, the X-ray image is observed visually on a fluorescent screen rather than recorded on a film. Option D, a fluoroscopy permits examination of thicker parts than does radiography. The correct answer is option A. Fluoroscopy uses a much lower kilovoltage than radiography. Fluoroscopy differs from radiography because in fluoroscopy, the X-ray image is observed visually on a fluorescent screen in real time, whereas in radiography, the X-ray image is recorded on a film for later viewing. This allows for dynamic imaging and the ability to observe the movement of internal structures in real time, which is not possible with radiography. Question 39. The density of a radiograph image refers to Option A, the thickness of the film. Option B, the thickness of the specimen. Option C, the weight of the film. Option D, The degree of film blackening. The correct answer is option D, the degree of film blackening. The density of a radiograph image refers to the degree of film blackening. Density is a measure of how much light is able to pass through the film. A higher density indicates a darker image, while a lower density indicates a lighter image. This is important in radiography as it helps to determine the contrast and visibility of structures within the image. The degree of film blackening is directly related to the amount of radiation that has been absorbed by the film, resulting in a higher density. Question 40. A densitometer is: option A, a meter used to measure X-ray intensity. Option B, an instrument for measuring film density. Option C, a meter used for measuring the density of a material. Option D, a meter used to measure tube current. The correct answer is option A, a meter used to measure X-ray intensity. A densitometer is an instrument used for measuring film density. Film density refers to the degree of darkness or opacity of a film, which can be used to determine the quality or characteristics of the film. A densitometer measures the amount of light that passes through the film and provides a numerical value that represents the density. This measurement is important in various industries such as photography, printing, and radiology, where the density of the film can affect the final output or interpretation of the image. Question 41. What do the voltage and waveform apply to the X-ray tube by a high-voltage transformer primarily determine? Option A, quantity of radiation. Option B, duration of exposure. Option C, penetrating ability. Option D, X-ray beam divergence. The correct answer is option C, penetrating ability. The voltage and waveform applied to the X-ray tube by a high-voltage transformer primarily determine the penetrating ability of the X-ray beam. The higher the voltage, the greater the penetrating ability of the X-rays. Additionally, the waveform can affect the quality and intensity of the X-ray beam, further influencing its ability to penetrate objects. Question 42. Which of the following materials is suitable for use in vessels or pails used to mix processing solutions? Option A, stainless steel. Option B, aluminum. Option C, galvanized iron. Option D, tin. The correct answer is option A, stainless steel. Stainless steel is suitable for use in vessels or pails used to mix processing solutions because it is corrosion-resistant, durable, and non-reactive. It can withstand the harsh chemicals and high temperatures often involved in processing solutions without contaminating the solution or being damaged itself. Aluminum, galvanized iron, and tin are not as suitable for this purpose as they may corrode or react with the chemicals in the solution, potentially contaminating it or compromising the integrity of the vessel. Question 43. The purpose of fixation is: option A, to remove the undeveloped salts of silver in the emulsion. Option B, to leave the formed silver as a permanent image. Option C, to harden the gelatin. Option D, all of the above. The correct answer is option A, to remove the undeveloped salts of silver in the emulsion. The purpose of fixation is to remove the undeveloped salts of silver in the emulsion, leaving only the formed silver as a permanent image. Fixation also helps to harden the gelatin, making the image more stable. Therefore, all of the given options are correct explanations for the purpose of fixation. Question 44. Unwanted inclusions, in part, will be appearing on a radiograph as: option A, a dark spot. Option B, a light spot. Option C, a generalized gray area of varying contrast. Option D, either a dark or light spot or area depending on the relative absorption ratio of the part material and the. The correct answer is option A, a dark spot. Unwanted inclusions in a radiograph can appear as either a dark spot, a light spot, or a generalized gray area of varying contrast. The appearance depends on the relative absorption ratio of the part material and the inclusion material. If the inclusion material has a higher absorption ratio than the part material, it will appear as a dark spot or area. Conversely, if the inclusion material has a lower absorption ratio, it will appear as a light spot or area. The contrast and appearance of the inclusion will vary depending on these absorption ratios. Question 45. If a piece of lead 1/2 inch is placed in the path of a beam of radiation emanating from cobalt-60, it will reduce the dose rate at a given location by: option A, 1/3, option B, 1/4, option C, 1/2, option D, 3/4. The correct answer is option C, 1/2. When a piece of lead is placed in the path of a beam of radiation, it acts as a shield and reduces the dose rate at a given location. In this case, the lead is 1/2 inch thick. The answer /1/2 suggests that the lead reduces the dose rate by half, meaning it cuts the radiation exposure in half. Question 46. The duration of exposure is usually controlled by Option A, controlling the milliamperage. Option B, a timer. Option C, controlling the source to film distance. Option D, a choke coil in the filament transformer. The correct answer is option B, a timer. The duration of exposure is usually controlled by a timer. A timer is used to set the specific amount of time that the X-ray machine will emit radiation. This is important in order to ensure that the patient receives the correct amount of radiation for their specific procedure. By using a timer, the healthcare professional can accurately control the duration of exposure and minimize the risk of overexposure to radiation. Question 47. For the best results while manually processing film, solutions should be maintained within a temperature range of Option A, 65°F and 75°F. Option B, 65°C and 75°C. Option C, 75°F and 85°F. Option D, 75°C and 85°C. The correct answer is option A, 65°F and 75°F. For the best results while manually processing film, solutions should be maintained within a temperature range of 65°F and 75°F. This temperature range is ideal because it provides the optimal conditions for developing the film. Temperatures outside of this range can negatively affect the development process, leading to issues such as under or overexposed images, color shifts, or graininess. Maintaining a consistent temperature within this range ensures accurate and high-quality film processing. Question 48. The focal spot size of an X-ray machine must be known in order to determine Option A, the geometric unsharpness value. Option B, kilovolt peak output. Option C, milliamperage settings. Option D, exposure time. The correct answer is option A, the geometric unsharpness value. The focal spot size of an X-ray machine must be known in order to determine the geometric unsharpness value. Geometric unsharpness refers to the blurring or loss of sharpness in an X-ray image, which can be caused by factors such as the size of the focal spot. A larger focal spot size can result in increased geometric unsharpness, leading to a less detailed and blurry image. Therefore, knowing the focal spot size is crucial in order to accurately calculate and minimize geometric unsharpness. Question 49. Primary radiation is considered to be any radiation that has not gone through a photoelectric effect. Option A, true. Option B, false. The correct answer is option true. The explanation for the given correct answer is that primary radiation refers to radiation that has not undergone any interactions or interactions other than scattering. The photoelectric effect is one of the interactions that can occur when radiation interacts with matter. Therefore, any radiation that has not gone through the photoelectric effect can be considered as primary radiation. Hence, the statement primary radiation is considered to be any radiation that has not gone through a photoelectric effect is true. Question 50. A graph showing the relation between material thickness, kilovoltage, and exposure time are known as Option A, a bar chart. Option B, an exposure chart. Option C, a characteristic curve. Option D, an HND curve. The correct answer is option B, an exposure chart. An exposure chart is a graph that displays the relationship between material thickness, kilovoltage, and exposure time. It is used in photography and radiology to determine the correct exposure settings for capturing an image. By plotting these variables on the chart, photographers and radiographers can easily determine the optimal combination of settings to achieve the desired image quality. The exposure chart helps in understanding how changes in material thickness, kilovoltage, and exposure time affect the overall exposure and allows for precise adjustments to be made. Question 51. A radioactive source with an activity of 1 curie has Option A, 1000 disintegrations per second taking place. Option B, 1 million disintegrations per second taking place. Option C, 1 billion disintegrations per second taking place. Option D, 3.7 times 10 to the power of 10th disintegrations per second taking place. The correct answer is option D, 3.7 times 10 to the power of 10th disintegrations per second taking place. The activity of a radioactive source is measured in curies, which represents the number of disintegrations per second taking place. In this case, the correct answer is 3.7 times 10 to the power of 10th disintegrations per second taking place. This means that the radioactive source is very active, with a large number of disintegrations occurring every second. Question 52. The wavelength of a typical X-ray is usually considered to be several miles long. Option A, true. Option B, false. The correct answer is option false. X and gamma rays are ms. In \angstrom units equals 0.00000001 cm, 10 to the minus 8 billionths. 1 cm equals 0.394 \. Question 53. Large grain films provide the best definition in a radiograph. Option A, true. Option B, false. The correct answer is option false. Small grain films provide best definition. Question 54. A cobalt-60 source has a half-life of option A, 1.2 years, option B, 6 months, option C, 5.3 years, option D, 75 days. The correct answer is option A, 1.2 years. Not available via AI. Question 55. Very short wavelength electromagnetic radiation is produced when electrons traveling at high speeds collide with matter is called option A, X radiation, option B, beta radiation, option C, gamma radiation, option D, none of the above. The correct answer is option A, X radiation. X radiation is produced when electrons traveling at high speeds collide with matter. This collision causes the electrons to emit very short wavelength electromagnetic radiation, which is known as X radiation. X-rays have the ability to penetrate matter and are commonly used in medical imaging and industrial applications. Beta radiation refers to the emission of high-energy electrons or positrons, while gamma radiation is a form of high-energy electromagnetic radiation. None of the other options correctly describe the specific type of radiation produced by high-speed electron collisions. Question 56. Unexposed boxes of X-ray film should be stored. Option A, flat. Option B, on edge or end. Option C, in a pile. Option D, it doesn't matter. The correct answer is option A, flat. X-ray film should be stored on edge or end to prevent damage. Storing them flat can lead to the film sticking together or warping. Storing them in a pile can also cause damage, as the weight of the boxes can crush the film. Therefore, storing them on edge or end is the best way to ensure the film remains in good condition and can be used effectively. Question 57. Why is cobalt-60 used as a radiation source for medium-weight metals of thickness ranging from 1.5 to 9 inches? Option A, because of its short half-life. Option B, a limited amount of shielding required. Option C, because of its penetrating ability. Option D, none of the above. The correct answer is option C, because of its penetrating ability. Cobalt-60 is used as a radiation source for medium-weight metals of thickness ranging from 1.5 to 9 inches because of its penetrating ability. This means that the radiation emitted by cobalt-60 can easily pass through the thickness of these metals, allowing for effective inspection and testing. The penetrating ability of cobalt-60 makes it an ideal choice for applications where thorough examination of the metal is required without the need for excessive shielding or the use of more powerful radiation sources. Question 58. Static marks, which are black tree-like or circular marks on a radiograph, are often caused by option A, film being bent when inserted in a cassette or holder. Option B, foreign material or dirt embedded in screens. Option C, scratches on lead foil screens. Option D, improper film handling techniques. The correct answer is option A, film being bent when inserted in a cassette or holder. Static marks on a radiograph can be caused by various factors such as film being bent when inserted in a cassette or holder, foreign material or dirt embedded in screens, and scratches on lead foil screens. However, the correct answer for the given question is \improper film handling techniques. This means that the static marks are likely caused by mistakes or errors made during the handling of the film, rather than the other mentioned factors. Question 59. The purpose of a dated decay curve is to: Option A, determine the source size at any time. Option B, calculate shielding requirements. Option C, determine the source strength, activity, at any time. Option D, mark the date and length of time for each exposure. The correct answer is option A, determine the source size at any time. A dated decay curve is used to determine the source strength or activity of a radioactive material at any given time. Radioactive materials decay over time, and the decay curve shows how the activity of the source decreases over time. By measuring the activity of the source at a specific time and comparing it to the decay curve, one can determine the current source strength. This information is crucial for various applications, such as monitoring radiation exposure, ensuring safety, and calculating appropriate shielding requirements. Question 60. While radiographing a part that contains a large crack, the crack will appear on the radiograph as: Option A, a dark, intermittent, or continuous line. Option B, a light, irregular line. Option C, either a dark or light line. Option D, a fogged area on the radiograph. The correct answer is option A, a dark, intermittent, or continuous line. When radiographing a part that contains a large crack, the crack will appear on the radiograph as a dark, intermittent, or continuous line. This is because the crack acts as a barrier to the penetration of X-rays, resulting in reduced exposure on the film. As a result, the crack appears darker compared to the surrounding area. The line may appear intermittent if the crack is not continuous throughout the part or if there are other factors affecting the X-ray exposure. Question 61. X-ray exposure may be due to: Option A, the direct beam from the X-ray tube target. Option B, scatter radiation arising from the object in the direct beam. Option C, both A and B above. Option D, both A and B above, plus residual radiation that exists for the first few minutes after the X-ray machine has. The correct answer is option A, the direct beam from the X-ray tube target. X-ray exposure can occur due to both the direct beam from the X-ray tube target and scatter radiation arising from the object in the direct beam. The direct beam refers to the primary X-ray beam that is emitted from the X-ray tube and directly interacts with the object being imaged. Scatter radiation, on the other hand, is produced when the primary X-ray beam interacts with the object and scatters in different directions. Both the direct beam and scatter radiation contribute to the overall X-ray exposure. Additionally, the answer also mentions residual radiation that exists for the first few minutes after the X-ray machine has been turned off, which further adds to the X-ray exposure. Question 62. As a check on the adequacy of the radiographic technique, it is customary to place a standard test piece on the source side of the specimen. This standard test piece is called a: Option A, reference plate. Option B, lead screen. Option C, penetrometer. Option D, illuminator. The correct answer is option C, penetrometer. A penetrometer is a standard test piece that is placed on the source side of the specimen during radiographic testing. It is used to check the adequacy of the radiographic technique. The penetrometer helps evaluate the quality of the radiographic image by providing a known level of contrast and resolution. It allows technicians to assess the penetration and visibility of the image produced by the radiographic technique. Therefore, the correct answer is penetrometer. Question 63. To prevent excessive backscatter from reaching a radiographic film, one should: Option A, back the cassette with a sheet of lead, the thickness needed depending on the radiation quality. Option B, place a mask between the specimen and the front surface of the film. Option C, back the exposure holder with a thick sheet of lead, at least 1/2 inch. Option D, place a filter in the X-ray or gamma ray beam near the source or X-ray tube. The correct answer is option A, back the cassette with a sheet of lead, the thickness needed depending on the radiation quality. Backing the cassette with a sheet of lead helps to prevent excessive backscatter from reaching the radiographic film. The thickness of the lead sheet needed depends on the radiation quality. Lead is a dense material that effectively absorbs and blocks radiation, reducing the amount of backscatter that can reach the film. By placing the lead sheet behind the cassette, it acts as a shield, preventing the backscatter from reaching the film and causing unwanted exposure or artifacts. The thickness of the lead sheet required will vary depending on the energy and intensity of the radiation being used. Question 64. The accidental movement of the specimen or film during exposure or the use of a focus film distance that is too small will. Option A. Produce a radiograph with poor contrast. Option B. Make it impossible to detect large discontinuities. Option C. Result in an unsharpness or the radiograph. Option D. Result in a fogged radiograph. The correct answer is option A. Produce a radiograph with poor contrast. Accidental movement of the specimen or film during exposure or using a focus film distance that is too small can result in unsharpness in the radiograph. This means that the image will be blurred or not well defined, making it difficult to see details and detect any large discontinuities. Poor contrast in a fogged radiograph may also occur, but the main consequence in this case is the unsharpness of the image. Question 65. What is the ability to detect a small discontinuity or flaw called? Option A. Radiographic contrast. Option B. Radiographic sensitivity. Option C. Radiographic density. Option D. Radiographic resolution. The correct answer is option B. Radiographic sensitivity. Radiographic sensitivity refers to the ability to detect small discontinuities or flaws in an image. It is a measure of how well a radiographic technique can detect subtle changes in density or contrast. A high level of sensitivity means that even small flaws or discontinuities can be easily identified in the image. Therefore, radiographic sensitivity is the most appropriate term to describe the ability to detect small discontinuities or flaws. Question 66. Who handles the source when doing gamma-ray radiography with high-intensity emitters? Option A. Directly by personnel equipped with special protective clothing Option B. By remote handling equipment. Option C. Directly by personnel with special protective clothing except when radiographs are being made. Option D. By the same methods used for low-intensity emitters. The correct answer is option B. By remote handling equipment. When performing gamma-ray radiography with high-intensity emitters, the source is handled by remote handling equipment. This means that personnel do not directly handle the source themselves, but instead use specialized equipment to manipulate the source from a safe distance. This is necessary because high-intensity emitters can pose a significant radiation hazard, and it is important to minimize the risk to personnel. Question 67. A beam of radiation consisting of a single wavelength is known as Option A. Characteristic radiation. Option B. Fluoroscopic radiation. Option C. Monochromatic radiation. Option D. A microscopic radiation. The correct answer is option C. Monochromatic radiation. Monochromatic radiation refers to a beam of radiation that consists of a single wavelength. This means that all the photons in the beam have the same energy level. This type of radiation is commonly used in scientific experiments and applications where precise control over the wavelength is required, such as in spectroscopy or laser technology. It is different from characteristic radiation, which refers to the specific wavelengths emitted by atoms during transitions between energy levels, and from fluoroscopic radiation, which is the radiation used in medical imaging. Microscopic radiation is not a recognized term in the context of radiation. Question 68. If a 500 keV photon enters an atom that has a binding force of 50 keV and removes an electron by giving it an energy of 50 keV, then the new photon would have an energy of 400 keV. Option A. True. Option B. False. The correct answer is option false. 500 keV 50 keV 50 keV equals 400 keV. Question 69. In order to decrease geometric unsharpness, Option A. Radiation should proceed from as small a focal spot as other considerations will allow. Option B. Radiation should proceed from as large a focal spot as other considerations will allow. Option C. The film should be as far as possible from the object being radiographed. Option D. The distance from the anode to the material examined should be as small as is practical. The correct answer is option A. Radiation should proceed from as small a focal spot as other considerations will allow. Geometric unsharpness refers to the blurring or lack of sharpness in an X-ray image. To decrease geometric unsharpness, it is important to have a small focal spot size. A smaller focal spot size allows for better spatial resolution and sharper images. However, other considerations such as heat dissipation and tube life should also be taken into account when determining the focal spot size. Therefore, radiation should proceed from as small a focal spot as other considerations will allow. Question 70. A general rule used to define the amount of radiation exposure that is excessive is: Option A. Any dose over 5 ARRT per week is excessive. Option B. Any dose which causes a mid-range reading on a Geiger counter is excessive. Option C. Any unnecessary exposure to radiation is excessive. Option D. Although small amounts of radiation, 0.4 ARRT per week or less, are beneficial since they build up an immunity to. The correct answer is option C. Any unnecessary exposure to radiation is excessive. The correct answer states that any unnecessary exposure to radiation is excessive. This means that if someone is exposed to radiation when it is not necessary or beneficial, it is considered excessive. This aligns with the general rule mentioned in the question that small amounts of radiation can be beneficial, but anything above that is excessive. Therefore, the statement that any unnecessary exposure to radiation is excessive is a valid explanation based on the information provided. Question 71. A graph that expresses the relationship between material thickness, kV, and time specific to film, machine, FFD, processing conditions, and the resulting photographic density is called: Option A. A bar chart. Option B. An exposure chart. Option C. The characteristic curve. Option D. A logarithmic chart. The correct answer is option A. A bar chart. Exposure charts are plotted on logarithmic scale but are still referred to as exposure charts. Question 72. The normal development time for manual processing of X-ray film is: Option A. 12 to 18 minutes in processing solutions at 75 F. Option B. 3 to 8 minutes in processing solutions at 60 F. Option C. 12 to 18 minutes in processing solutions at 68 C. Option D. 5 to 8 minutes in processing solutions at 68 F. The correct answer is option D. 5 to 8 minutes in processing solutions at 68 F. The normal development time for manual processing of X-ray film is 5 to 8 minutes in processing solutions at 68 F. This temperature range is optimal for the chemical reactions involved in developing the film. Higher temperatures can lead to overdevelopment and lower temperatures can result in underdevelopment. Therefore, maintaining the film in the processing solutions at 68 F for 5 to 8 minutes ensures the proper development of the X-ray film. Question 73. The radiation intensity of a radioisotope: Option A. Increases with time. Option B. Decreases with time. Option C. Is not affected as time elapses. Option D. None of the above. The correct answer is option B. Decreases with time. Radioisotopes are unstable and undergo radioactive decay, which involves the emission of radiation. As time passes, the number of radioactive atoms in a sample decreases due to decay. This leads to a decrease in the radiation intensity of the radioisotope. Therefore, the correct answer is that the radiation intensity of a radioisotope decreases with time. Question 74. X and gamma rays differ in that the gamma ray is actually a particle of matter that has both mass and weight. Option A. True. Option B. False. The correct answer is option false. X and gamma rays have no mass or weight. Question 75. A good radiograph is obtained using a milliamperage of 15 milliamperes and an exposure time of 1/2 minute. What exposure time will be necessary to produce an equivalent radiograph if the milliamperage is changed to 5 milliamperes and all other conditions remain the same? Option A. 4.5 minutes. Option B. 1.5 minutes. Option C. 3 minutes. Option D. 1/6 minute. The correct answer is option B. 1.5 minutes. If the milliamperage is changed from 15 milliamperes to 5 milliamperes, the exposure time needs to be adjusted to compensate for the decrease in milliamperage. Since the milliamperage is reduced by a factor of 3, the exposure time needs to be increased by a factor of 3 to maintain the same level of radiation exposure. Therefore, the new exposure time would be 3 times 1/2 minute, which equals 1.5 minutes. Question 76. The velocity of all electromagnetic radiation is: Option A. 186,000 miles per second. Option B. 18,600 miles per second. Option C. 1,860,000 miles per second. Option D. 1,860. The correct answer is option A. 186,000 miles per second. The correct answer is 186,000 miles per second. This is the speed of light in a vacuum, and it is a constant value for all forms of electromagnetic radiation. It is denoted by the symbol /c/ and is approximately equal to 299,792,458 meters per second. This speed is a fundamental constant in physics and plays a crucial role in various scientific theories and calculations. Question 77. A properly exposed radiograph that is developed in a developer solution at a temperature of 58 F for 5 minutes will probably be Option A, overdeveloped. Option B, underdeveloped. Option C, fogged. Option D, damaged by frilling. The correct answer is Option B, underdeveloped. A radiograph that is developed in a developer solution at a lower temperature and for a shorter duration than recommended will likely result in underdeveloped image. The lower temperature and shorter time period would not allow the developer solution to fully react with the exposed areas of the radiograph, leading to insufficient darkening and contrast in the image. This would result in an underdeveloped radiograph with less detail and visibility. Question 78. Penetrometers for blank are considered Group 1 materials and need not have an identification notch. Option A, inconel. Option B, nickel. Option C, stainless steel. Option D, aluminum bronze. The correct answer is Option C, stainless steel. Penetrometers for stainless steel are considered Group 1 materials and need not have an identification notch. This means that when conducting radiographic testing or inspection using penetrometers made of stainless steel, there is no requirement to include an identification notch on them. This is because stainless steel is already classified as a Group 1 material, which indicates that it has excellent radiographic properties and does not require additional identification markings for accurate testing. Question 79. Atoms, molecules, and various subatomic particles which carry either a positive or negative electrical charge are called Option A, photoelectrons. Option B, photons. Option C, ions. Option D, compounds. The correct answer is Option A, photoelectrons. Atoms, molecules, and subatomic particles that carry an electrical charge are called ions. Ions can be either positively charged, cations, or negatively charged, anions, due to the gain or loss of electrons. Photoelectrons are electrons emitted from a surface when exposed to light, photons are particles of light, and compounds are substances formed by the chemical combination of elements. Question 80. What does the T refer to while referring to a/2T/ or /4T/ hole in the ASTM penetrometer? Option A, the part thickness. Option B, the penetrometer thickness. Option C, the time of exposure. Option D, the time for developing. The correct answer is Option B, the penetrometer thickness. The term /T/ in the ASTM penetrometer refers to the penetrometer thickness. This means that when referring to a/2T/ or /4T/ hole, it indicates that the hole diameter is twice or 4 times the thickness of the penetrometer. This is important in non-destructive testing as it helps determine the size and depth of flaws or defects in a material. Question 81. The intensity of 10 or gamma radiation is measured in Option A, Röntgens. Option B, ergs. Option C, Röntgens per unit of time. Option D, HND units. The correct answer is Option A, Röntgens. The intensity of 10 or gamma radiation is measured in Röntgens per unit of time because Röntgens per unit of time is a standard unit for measuring the amount of radiation absorbed by a material over a specific period. This measurement is important in assessing the potential health risks associated with exposure to radiation and in determining appropriate safety measures. The other options, such as Röntgens, ergs, and HND units, are not specifically used to measure the intensity of radiation over time. Question 82. X-rays, gamma rays, and alpha particles all have one thing in common: they are all Option A, particulate radiations. Option B, electromagnetic radiations. Option C, microwave radiations. Option D, ionizing radiations. The correct answer is Option D, ionizing radiations. X-rays, gamma rays, and alpha particles are all forms of radiation that have enough energy to remove tightly bound electrons from atoms, leading to the formation of charged particles called ions. This process is known as ionization. Therefore, these types of radiation are classified as ionizing radiations. Question 83. Rays from the X-ray source should be parallel to the plane of the film. Option A, true. Option B, false. The correct answer is option false. The source should be perpendicular to prevent /distortion /. Question 84. Excessive voltage across the X-ray tube will cause static marks on the radiographic film. Option A, true. Option B, false. The correct answer is option false. Static marks, artifacts, are due improper film handling. Question 85. Short wavelength electromagnetic radiation is produced during the disintegration of nuclei or radioactive substances and is called Option A, X radiation. Option B, gamma radiation. Option C, scatter radiation. Option D, backscatter radiation. The correct answer is option B, gamma radiation. Gamma radiation is the correct answer because it is a form of short wavelength electromagnetic radiation that is produced during the disintegration of nuclei or radioactive substances. It is highly penetrating and can cause ionization in matter. X radiation is also a form of electromagnetic radiation, but it is not specifically produced during the disintegration of nuclei or radioactive substances. Scatter radiation and backscatter radiation refer to the scattering of radiation in different directions, but they are not specific to the disintegration of nuclei or radioactive substances. Question 86. When the energy form of an X-ray tube has penetrated through 3 half-value layers, only 3/4 of the original energy remains. Option A, true. Option B, false. The correct answer is option false. 0.125 equals 1/8. Question 87. Because of the faster exposure time, the larger grain X-ray film will have the sharpest image. Option A, true. Option B, false. The correct answer is option false. Large grains lack detail. Question 88. Artifacts are often caused by improper use of safe lights in the darkroom. Option A, true. Option B, false. The correct answer is option false. Dust, improper handling, static marks etc. are the cause of artifacts. Question 89. Which has the shortest wavelengths? Option A, visible light. Option B, microwaves. Option C, 100 kV peak X-rays. Option D, infrared radiation. The correct answer is option A, visible light. X-rays have the shortest wavelengths among the given options. X-rays are a form of electromagnetic radiation with high energy and short wavelengths, ranging from about 0.01 to 10 nanometers. They are shorter in wavelength than visible light, microwaves, and infrared radiation. The high energy and short wavelength of X-rays make them suitable for medical imaging and industrial applications such as material inspection and non-destructive testing. Question 90. An advantage of radiography is that it reveals internal discontinuities with access to only one side of the part being inspected. Option A, true. Option B, false. The correct answer is option false. Radiography specimens must lend itself to two-sided accessibility. Question 91. White crescent-shaped marks on an exposed X-ray film are most likely caused by Option A, crimping film after exposure. Option B, crimping film before exposure. Option C, sudden extreme temperature change while processing. Option D, a warm of exhausted fixer. The correct answer is option B, crimping film before exposure. Crimping film before exposure can cause white crescent-shaped marks on an exposed X-ray film. This is because when the film is crimped before exposure, it can create pressure points that prevent proper development of the film in those areas. As a result, those areas appear as white crescent-shaped marks on the film. Question 92. What happens if the foil is in direct contact with X-ray film? Option A, intensifies the scatter radiation more than the primary radiation. Option B, decreases the contrast of the radiographic image. Option C, intensifies the primary radiation more than in comparison to the scatter radiation. Option D, should not be used when gamma rays are emitted by the source of radiation. The correct answer is option A, intensifies the scatter radiation more than the primary radiation. When the foil is in direct contact with X-ray film, it intensifies the primary radiation more than the scatter radiation. This means that the foil enhances the strength of the primary X-rays that reach the film, while having a lesser effect on the scattered X-rays. This can result in a higher overall exposure and intensity of the primary X-rays in the radiographic image, potentially leading to increased image quality and clarity. Question 93. A penetrometer is used to indicate: Option A, the size of the discontinuities in a part. Option B, the density of the film. Option C, the amount of the film contrast. Option D, the quality of the radiographic technique. The correct answer is option D, the quality of the radiographic technique. A penetrometer is a device used in radiographic testing to assess the quality of the radiographic technique. It consists of a series of step wedges or image quality indicators that have different thicknesses. When the penetrometer is exposed to radiation, the resulting radiographic image shows the varying degrees of penetration of the radiation through the different thicknesses. By analyzing the image, technicians can determine the quality of the radiographic technique used, including factors such as exposure settings, film processing, and overall image clarity. Question 94. The formula for determining permissible accumulated personnel doses. Option A, 12, N18. Option B, 18, 5 plus N. Option C, 5, N18. Option D, 12, N plus 18. The correct answer is option C, 5, N18. The correct formula for determining permissible accumulated personnel dose is 5, N18. This formula suggests that the permissible dose is calculated by subtracting 18 from the value of N, and then multiplying it by 5. This means that the permissible dose increases as the value of N increases, but decreases as the value of N gets closer to 18. Question 95. A large source size can be compensated for by: Option A, increasing the source to specimen distance. Option B, the addition of LED screens. Option C, increasing the specimen to film distance. Option D, increasing penumbra. The correct answer is option A, increasing the source to specimen distance. Increasing the source to specimen distance can compensate for a large source size because it helps to reduce the penumbra, which is the blurring effect caused by the finite size of the radiation source. By increasing the distance between the source and the specimen, the penumbra is decreased, resulting in a sharper image. This is particularly important in radiography, where a clear and detailed image is necessary for accurate diagnosis. Additionally, increasing the source to specimen distance can also help to reduce the scatter radiation, further improving image quality. Question 96. The selection of one test method over another is usually the decision of the LVLI technician performing the test. Option A, true. Option B, false. The correct answer is option false. LVL2 is qualified to set up and calibrate equipment and to interpret and evaluate results with respect to codes, etc. Question 97. L9. When safe lights are used in the darkroom, there is no danger of the X-ray film being /fogged, /. Option A, true. Option B, false. The correct answer is option false. Safe lights lessen the danger of exposing film. Question 98. Reticulation resulting in a puckered or net-like film surface is probably caused by: Option A, crimping film after exposure. Option B, sudden extreme temperature change while processing. Option C, water or developer on unprocessed film. Option D, excessive object-to-film distance. The correct answer is option B, sudden extreme temperature change while processing. Reticulation resulting in a puckered or net-like film surface is probably caused by sudden extreme temperature change while processing. This occurs when there is a rapid and drastic change in temperature during the film development process. The sudden temperature change causes the film emulsion to contract and expand unevenly, leading to the formation of a puckered or net-like pattern on the film surface. This can result in a distorted and damaged image on the film. Question 99. A curie is an equivalent of: Option A, 0.001 millicuries. Option B, 1.000 millicuries. Option C, 1.000 megacuries. Option D, 100 megacuries. The correct answer is option B, 1.000 millicuries. A curie is a unit of measurement used to quantify the amount of radioactivity in a substance. The given answer, 1.000 millicuries, states that a curie is equivalent to 1.000 millicuries. This means that 1 millicurie is equal to 1,000th of a curie. Question 100. The most widely used unit of measurement to measure the rate at which the output of a gamma-ray source decays is the Option A, curie. Option B, Röntgen. Option C, half-life. Option D, MeV. The correct answer is Option A, curie. The curie is the most widely used unit of measurement to measure the rate at which the output of a gamma-ray source decays. It is a unit of radioactivity that represents the number of radioactive disintegrations per second in a given sample. The curie is commonly used in the field of nuclear medicine and radiation therapy to quantify the amount of radiation emitted by a source. The other options, such as Röntgen, half-life, and MeV, are not specifically used to measure the rate of decay of a gamma-ray source. Question 101. The image of the required penetrometer and hole on the radiograph indicates that the radiograph has the required Option A, contrast. Option B, definition. Option C, sensitivity. Option D, latitude. The correct answer is Option A, contrast. The image of the required penetrometer and hole on the radiograph suggests that the radiograph has the required sensitivity. Sensitivity refers to the ability of the radiograph to accurately capture and display subtle differences in density or contrast. In this case, the fact that the penetrometer and hole are clearly visible indicates that the radiograph is sensitive enough to capture these details. Question 102. A LVLI technician performing a radiographic test is permitted to accept or reject the part provided that written instructions or procedures are given to him by a LVL2 or LVL3. In accordance with SNTTC 1A. Option A, true. Option B, false. The correct answer is option false. Those are the duties of a LVL2 qualified to set up and calibrate equipment and to interpret and evaluate results with respect to codes. Question 103. Lead foil screens are used in radiography. Option A. To improve the quality of the radiograph by preferentially reducing the effect of scatter radiation. Option B. To reduce the exposure time. Option C. Both A and B are reasons for using lead foil screens. Option D. Neither A nor B are reasons for using lead foil screens. The correct answer is Option A. To improve the quality of the radiograph by preferentially reducing the effect of scatter radiation. Lead foil screens are used in radiography to improve the quality of the radiograph by preferentially reducing the effect of scatter radiation. Scatter radiation is unwanted radiation that can degrade the quality of the image by causing blurring and reducing contrast. Lead foil screens can absorb or scatter this radiation, thereby improving the clarity and sharpness of the radiograph. Additionally, lead foil screens can also reduce the exposure time required for obtaining a clear image, as they help to enhance the signal-to-noise ratio by reducing the amount of scatter radiation reaching the detector. Therefore, both A and B are valid reasons for using lead foil screens in radiography. Question 104. With a given exposure time and kilovoltages, a properly exposed radiograph is obtained with a 6 mA exposure at a distance of 20 inches. It is required to increase the sharpness of detail in the image by increasing the source-to-film distance to 40 inches. The correct milliamperes-minutes exposure to obtain the desired radiographic density at the increased distance is Option A, 12 milliamperes-minutes. Option B, 24 milliamperes-minutes. Option C, 3 milliamperes-minutes. Option D, 1.7 milliamperes-minutes. The correct answer is Option A, 12 milliamperes-minutes. Increasing the source-to-film distance from 20 inches to 40 inches will result in a decrease in the radiographic density. To compensate for this decrease and maintain the desired radiographic density, the milliamperes-minutes exposure needs to be doubled. Since the original exposure was 6 milliamperes-minutes, the correct milliamperes-minutes exposure at the increased distance would be 12 milliamperes-minutes. Question 105. In film radiography, the penetrometers are mostly placed. Option A. In between the intensifying screen and the film. Option B. On the source side of the object for testing. Option C. On the film side of the test object for testing. Option D. In between the operator and the radiation source. The correct answer is Option B. On the source side of the object for testing. In film radiography, the penetrometers are mostly placed on the source side of the object for testing. This is because penetrometers are used to measure the quality of the X-ray beam and the overall system performance. By placing the penetrometers on the source side, they can accurately assess the X-ray beam before it interacts with the object being tested. This allows for better evaluation of the image quality and detection of any potential flaws or defects in the object. Question 106. Water spots on the films can be decreased by Option A. Rapid drying of wet film. Option B. Immersing wet film for 1 or 2 minutes in a wetting agent solution. Option C. By using a fresh fixer solution. Option D. By cascading water during the rinse cycle. The correct answer is option B. Immersing wet film for 1 or 2 minutes in a wetting agent solution. Immersing wet film for 1 or 2 minutes in a wetting agent solution can decrease water spots on the films. Wetting agents are substances that reduce the surface tension of water, allowing it to spread more evenly and easily over the film surface. By immersing the wet film in a wetting agent solution, the water spots are minimized as the solution helps to disperse and remove any remaining water droplets on the film. This process ensures a more even and rapid drying of the film, resulting in a cleaner and spot-free final product. Question 107. Two X-ray machines operating at the same nominal kilovoltage and milliamperage settings. Option A. Will produce the same intensities and qualities of radiation. Option B. Will produce the same intensities but may produce different qualities of radiation. Option C. Will produce the same qualities but may produce different intensities of radiation. Option D. May give not only different intensities but also different qualities of radiation. The correct answer is option D. May give not only different intensities but also different qualities of radiation. Two X-ray machines operating at the same nominal kilovoltage and milliamperage settings may give not only different intensities but also different qualities of radiation. This is because the quality of radiation produced by an X-ray machine is determined by the energy level of the X-ray photons, which can vary depending on the design and characteristics of the machine. The intensity of radiation, on the other hand, refers to the number of X-ray photons produced per unit of time, which can also vary between machines. Therefore, even with the same settings, the X-ray machines may produce different intensities and qualities of radiation. Question 108. The term /absorption refers to the ability of a material to permit X-rays to penetrate without loss of energy. Option A, true. Option B, false. The correct answer is option false. Absorption is dependent upon the thickness and density at that point. Absorption, the ability of the specimen to block the passage of X-rays through the material. Question 109. Gradual changes in specimen thickness produce radiographs that show excellent definition. Option A, true. Option B, false. The correct answer is option false. An abrupt change in thickness produces excellent definition. Question 110. A general rule often employed for determining the kilovoltage to be used when X-raying a part is: Option A. The kilovoltage should be as high as other factors will permit. Option B. The kilovoltage should be as low as other factors will permit. Option C. The kilovoltage is always a fixed value and cannot be changed. Option D. The kilovoltage is not an important variable and can be changed over a wide range without affecting the radiograph. The correct answer is option B. The kilovoltage should be as low as other factors will permit. The explanation for the given correct answer is that the kilovoltage should be as low as other factors will permit. This is because using a lower kilovoltage helps to reduce the radiation dose to the patient while still producing a diagnostic image. However, it is important to note that the kilovoltage should not be set too low as it may result in poor image quality and reduced visibility of certain structures. Therefore, the kilovoltage should be adjusted based on other factors such as the thickness of the body part being imaged and the desired level of image detail. Question 111. L5A X-ray travels faster than A/soft X-ray, and that is why the hard X-rays have more energy. Option A, true. Option B, false. The correct answer is option false. Regardless of Curie strength, activity, size of an isotope, the energy of individual rays remains the same. Question 112. What happens if a film is placed in a developer solution and allowed to develop without any agitation? Option A. The radiograph will not show proper contrast. Option B. It will become impossible to fix the radiograph permanently. Option C. There will be a usual fogging condition over the entire radiograph. Option D. There will be a tendency for each area of the film to affect the development of the areas immediately below. The correct answer is option A. The radiograph will not show proper contrast. If a film is placed in a developer solution and allowed to develop without any agitation, there will be a tendency for each area of the film to affect the development of the areas immediately below it. This means that the developer solution will not be evenly distributed across the film, resulting in uneven development. This can lead to variations in density and contrast in different areas of the radiograph, making it difficult to interpret the image accurately. Question 113. An unshielded isotope source gives a dosage rate of 900 ml per hour at 10 feet. What would the unshielded dosage rate be at 30 feet? Option A, 300 ml/Hr. Option B, 600 ml/Hr. Option C, 100 ml/Hr. Option D, 2700 ml/Hr. The correct answer is option C, 100 ml/Hr. The dosage rate of an unshielded isotope source decreases as the distance from the source increases. This is because the radiation spreads out and becomes less concentrated. In this case, the dosage rate at 30 feet would be lower than the dosage rate at 10 feet. Since the correct answer is 100 ml/Hr, it means that the dosage rate decreases by a factor of 9 as the distance triples from 10 feet to 30 feet. Question 114. A section with a significant increase in thickness variation is required to be shown on a single radiograph within a desired film density range. This may be accomplished by Option A, increasing kilovoltage. Option B, using a coarser grain film. Option C, both A and B are correct. Option D, neither A nor B is correct. The correct answer is option A, increasing kilovoltage. Increasing kilovoltage in radiography will result in a higher energy X-ray beam, which can penetrate thicker objects more effectively. This means that a section with a significant increase in thickness variation can be shown on a single radiograph within a desired film density range by increasing the kilovoltage. The higher energy X-rays will be able to pass through the thicker sections and create a proper image on the film. Using a coarser grain film will not have the same effect as increasing kilovoltage, so it is not the correct answer. Question 115. The term used to express the number of curies of radioactivity per gram or ounce of source weight is Option A, decay. Option B, emissivity. Option C, specific activity. Option D, source output. The correct answer is option C, specific activity. Specific activity is the term used to express the number of curies of radioactivity per gram or ounce of source weight. It is a measure of the radioactivity concentration in a given amount of material. The specific activity allows for comparison of different radioactive sources based on their radioactivity per unit mass. It is an important parameter in radiation safety and in the field of nuclear medicine, where specific activity is used to determine the dosage of radioactive drugs or tracers. Question 116. Approximately what % of the original radioactivity is left after 6 half-lives? Option A, 0.05. Option B, 10. Option C, 33.3. Option D, 2. The correct answer is option D, 2. After each half-life, the amount of radioactive material is reduced by half. Therefore, after 6 half-lives, the amount of original radioactivity remaining would be 1/2 asterisk 1/2 asterisk 1/2 asterisk 1/2 asterisk 1/2 asterisk 1/2 equals 1/64, which is approximately 0.0156. Since this value is closest to 0.01, the answer is 2, which represents 2% of the original radioactivity remaining. Question 117. Primary radiation which strikes a film holder or cassette through a thin portion of the specimen will cause scattering into the shadows of the adjacent thicker portions, producing an effect called Option A, radiation imaging. Option B, spotting. Option C, undercut. Option D, unsharpness. The correct answer is option C, undercut. When primary radiation passes through a thin portion of the specimen and strikes a film holder or cassette, it can cause scattering into the shadows of the adjacent thicker portions. This scattering effect is known as undercut. Question 118. Frilling or loosening of the emulsion from the base of the film is most likely caused by Option A. The water of developer on unprocessed film. Option B. The low temperature of processing solutions. Option C. Developer solution contamination. Option D. A warm or exhausted fixer solution. The correct answer is Option D. Warm or exhausted fixer solution. The frilling or loosening of the emulsion from the base of the film is most likely caused by a warm or exhausted fixer solution. This is because the fixer solution is responsible for removing the unexposed silver halide crystals from the film, and if the solution is too warm or exhausted, it can cause the emulsion to separate from the base. This can result in a loss of image quality and potentially damage the film. Question 119. The radiation quality of a manta ray source is Option A. Determined by the size of the focal spot. Option B. Determined by the isotope involved. Option C. Can be varied by the operator. Option D. Is greater in iridium-192 than in cobalt-60. The correct answer is Option B. Determined by the isotope involved. The radiation quality of a manta ray source is determined by the isotope involved. Different isotopes have different properties and emit radiation of varying qualities. The specific isotope used in the manta ray source will determine the characteristics of the radiation it emits. The size of the focal spot and the ability to vary the radiation quality by the operator are not factors that determine the radiation quality of a manta ray source. Additionally, it is stated that the radiation quality is greater in iridium-192 than in cobalt-60, further supporting the fact that the isotope involved determines the radiation quality. Question 120. In making an isotope exposure in an unshielded area, you find the dose rate 6 feet from the source is 1200 mr/Hr. What would be the dose rate at 24 feet? Option A, 75 mr/Hr. Option B, 100 mr/Hr. Option C, 200 mr/Hr. Option D, 300 mr/Hr. The correct answer is Option A, 75 mr/Hr. The dose rate at a given distance from a radioactive source decreases as the distance increases. This relationship follows the inverse square law, which states that the intensity of radiation is inversely proportional to the square of the distance from the source. In this case, the dose rate is given as 1200 mr/Hr at 6 feet. To find the dose rate at 24 feet, we can use the inverse square law equation, dose rate at 6 feet, / dose rate at 24 feet, equals, distance at 24 feet, (2) / distance at 6 feet, (2). Solving for the dose rate at 24 feet gives us 75 mr/Hr. Question 121. Beta particles are Option A, neutrons. Option B, protons. Option C, electrons. Option D, positrons. The correct answer is Option C, electrons. Beta particles are high-energy electrons or positrons that are emitted during radioactive decay. In this case, the correct answer is positrons. Positrons are positively charged particles with the same mass as electrons, but opposite charge. They are produced when a proton in the nucleus of an atom converts into a neutron, releasing a positron and a neutrino. Positrons have a short lifespan as they quickly annihilate with electrons, resulting in the release of gamma rays. Question 122. If an exposure time of 60 seconds was necessary using a 4-foot source-to-film distance for a particular exposure, what time would be necessary if a 2-foot source-to-film distance is used and all other variables remain the same? Option A, 120 seconds. Option B, 30 seconds. Option C, 15 seconds. Option D, 240 seconds. The correct answer is Option A, 120 seconds. 225 Always square time-distance relations. Question 123. Lead screens in contact with the film during exposure. Option A. Absorb the shorter wavelength scattered radiation more than the long wavelength primary radiation. Option B. Intensify the photographic effect of the scatter radiation more than that of the primary radiation. Option C. None of the above. Option D. Increase the photographic action on the film largely by reason of the electron emission and partly by the secondary X. The correct answer is Option A. Absorb the shorter wavelength scattered radiation more than the long wavelength primary radiation. Lead screens in contact with the film during exposure increased the photographic action on the film largely by reason of the electron emission and partly by the secondary X-rays generated in the lead. This means that the lead screens enhance the exposure of the film by emitting electrons and generating secondary X-rays, which contribute to the overall photographic effect on the film. Question 124. Visible light has a longer wavelength than X and gamma rays. Option A, true. Option B, false. The correct answer is option false. X and gamma rays have a higher wavelength. Question 125. Backscattered radiation is often caused by low-energy X-rays whose electron path was changed within the film. Option A, true. Option B, false. The correct answer is option false. Backscatter equals scatter residing from the back of the film. Question 126. Water spots are usually caused by leaving the film in the rinse tank or in excess time. Option A, true. Option B, false. The correct answer is option false. Water spots are caused by hard water. Question 127. Coarse-grained films are advantageous because they require considerably less time in the developer, stop bath, and fixer solutions. Option A, true. Option B, false. The correct answer is option false. Advantageous to make exposures as fast as possible. Question 128. One requirement for keeping fluorescent screens in good condition is that they must: Option A, be cleaned with a lint-free cloth each time they are used. Option B, not be exposed to intense ultraviolet radiation. Option C, be mounted in a rigid container at all times. Option D, not be exposed to caustic fumes. The correct answer is option B, not be exposed to intense ultraviolet radiation. Fluorescent screens must not be exposed to intense ultraviolet radiation in order to keep them in good condition. This is because intense ultraviolet radiation can damage the fluorescent material and reduce its effectiveness. Therefore, it is important to protect the screens from such radiation to ensure their longevity and proper functioning. Question 129. The sharpness of the outline in the image of the radiograph is a measure of: Option A, subject contrast. Option B, radiographic definition. Option C, radiographic contrast. Option D, film contrast. The correct answer is option A, subject contrast. The sharpness of the outline in the image of the radiograph refers to the clarity and distinctness of the edges and details captured in the image. It is a measure of radiographic definition, which is the ability of the imaging system to accurately reproduce the anatomical structures and their boundaries. Subject contrast refers to the differences in density and brightness between different tissues or structures within the patient. Radiographic contrast refers to the overall range of densities and brightness levels in the image. Film contrast refers to the characteristics of the film used to capture the image. Question 130. In a fluoroscopic inspection system using a 15-inch source-to-material distance and 2-inch material-to-screen distance, transverse vibration of which item will cause the most image blurring? Option A, source vibration. Option B, screen vibration. Option C, material vibration. Option D, equal effects. The correct answer is option C, material vibration. Material vibration will cause the most image blurring in a fluoroscopic inspection system. This is because the material is closest to the screen, and any vibrations in the material will directly affect the image on the screen. The source and screen vibrations are further away from the screen and will have less of an impact on the image quality. Therefore, material vibration is the most significant factor in causing image blurring in this system. Question 131. If backscatter is suspected of causing a loss of definition, a lead letter can be placed between the film and the specimen to indicate possible scattered radiation. Option A, true. Option B, false. The correct answer is option false. Lead letter /B/S are placed in the back of the cassette, film, and specimen. Question 132. The purpose of agitating an X-ray film during development is to: Option A, protect the film from excessive pressure. Option B, renew the developer at the surface of the film. Option C, disperse unexposed silver grains on the film surface. Option D, prevent reticulation. The correct answer is option B, renew the developer at the surface of the film. Agitating an X-ray film during development helps to renew the developer at the surface of the film. This is important because the developer solution can become depleted or exhausted over time, leading to uneven development and reduced image quality. By agitating the film, fresh developer is brought into contact with the surface of the film, ensuring that the development process is consistent and complete. This helps to produce clear and well-defined X-ray images. Question 133. An advantage of the pocket dosimeter type of ionization chamber used to monitor radiation received by personnel is: Option A. It provides a permanent record of accumulated dosage. Option B. It provides an immediate indication of dosage. Option C. It is the most sensitive detector available. Option D. All of the above are advantages. The correct answer is option B. It provides an immediate indication of dosage. The advantage of the pocket dosimeter type of ionization chamber used to monitor radiation received by personnel is that it provides an immediate indication of dosage. This means that individuals wearing the pocket dosimeter can quickly and easily see the current level of radiation they have been exposed to. This immediate feedback allows for prompt action to be taken if the dosage reaches unsafe levels, ensuring the safety of personnel. Question 134. A fluoroscopic installation utilizing a fluorescent screen requires: Option A. A screen support with lead foil screens to control scatter. Option B. Lead glass, mirrors, or other means for transmitting the fluorescent image without subjecting the operator to X radiation. Option C. Both of the above. Option D. Neither of the above. The correct answer is option B. Lead glass, mirrors, or other means for transmitting the fluorescent image without subjecting the operator to X radiation. A fluoroscopic installation utilizing a fluorescent screen requires lead glass, mirrors, or other means for transmitting the fluorescent image without subjecting the operator to X radiation. This is because fluoroscopy involves the use of X-rays to create real-time images of the internal structures of the body. The lead glass, mirrors, or other means are necessary to allow the operator to view the fluorescent image without being exposed to the harmful X radiation. The lead foil screens, on the other hand, are used to control scatter radiation and are not directly related to transmitting the image to the operator. Therefore, the correct answer is lead glass, mirrors, or other means for transmitting the fluorescent image without subjecting the operator to X radiation. Question 135. The activity of the developer solution is maintained stable by: Option A. Constant agitation. Option B. Maintaining the processing solutions within the recommended temperature range. Option C. Avoiding contamination from the wash bath. Option D. The addition of replenisher. The correct answer is option D. Addition of replenisher. The addition of replenisher helps to maintain the activity of the developer solution stable. Replenisher is a solution that is added to the developer solution to restore any chemicals that may have been depleted during the development process. By adding replenisher, the necessary chemicals are replenished, ensuring that the developer solution remains effective and stable. This helps to produce consistent and high-quality results in the development process. Question 136. A sheet of lead with an opening cut in the shape of the part to be radiographed may be used to decrease the effect of scattered radiation which undercuts the specimens. Such a device is called: Option A. A mask. Option B. A filter. Option C. A backscatter absorber. Option D. A lead foil screen. The correct answer is option A. A mask. A sheet of lead with an opening cut in the shape of the part to be radiographed is called a mask. This device is used to decrease the effect of scattered radiation that undercuts the specimens. By placing the mask over the part, it blocks the scattered radiation from reaching the film or detector, resulting in a clearer and more accurate image. The mask acts as a barrier, preventing the scattered radiation from interfering with the desired radiographic image of the part. Question 137. A control strip that has been exposed under a step wedge and processed after each replenishment is also used to check excess fogging caused by safe lights. Option A. True. Option B. False. The correct answer is option false. Control strips are processed and split into stored strips and used as test strips and compared to determine replenishment when necessary. Question 138. The reason A/shim/ is used in radiographic setup is to: Option A. Improve the penetrameter image. Option B, reduce diffraction. Option C, simulate weld reinforcement. Option D, intensify the image. The correct answer is option C, simulate weld reinforcement. A/shim/ is a thin piece of material that is used to simulate weld reinforcement in a radiographic setup. Weld reinforcement refers to the excess material that is intentionally added to a weld joint to ensure its strength and durability. By using a shim, the radiographic image will show the presence of weld reinforcement, allowing inspectors to assess the quality and integrity of the weld. This helps in ensuring that the weld meets the required standards and specifications. Question 139. Replenishment of the developer is necessary when the densities on the control strip start to become darker. Option A, true. Option B, false. The correct answer is option false. Weakened developer equals lighter film. Question 140. ASNT provides a service for examining LVL 1, 2, and 3 personnel in the general and specific areas. Option A, true. Option B, false. The correct answer is option false. SNTTC1A doc recommends that NDT LVL3 be examined in A, basic, B, method, C, specific. Question 141. Film graininess greatly affects the amount of penumbra on a radiograph. Option A, true. Option B, false. The correct answer is option false. Film graininess affects definition. Whenever penumbra can be reduced, it will also improve the definition. Question 142. If a fluorescent screen is accidentally exposed to unattenuated X-rays, which of the following occurs? Option A, intense heat generated in the screen will permanently destroy the screen crystals. Option B, screen blackens due to overexposure. Option C, the screen is essentially undamaged. Option D, screen sensitivity and light level will be permanently reduced. The correct answer is option C, the screen is essentially undamaged. When a fluorescent screen is accidentally exposed to unattenuated X-rays, the screen is essentially undamaged. This is because fluorescent screens are designed to convert X-rays into visible light, allowing for the visualization of the X-ray image. However, if the screen is exposed to excessive X-ray radiation, it may become overexposed and appear blackened. In this case, the screen has not been permanently damaged, but its sensitivity and light level may be reduced. The intense heat generated by the X-rays does not destroy the screen crystals, as they are designed to withstand such radiation. Question 143. One of the general rules concerning the application of geometric principles of shadow formation to radiography is: Option A. The X-rays should proceed from as large a focal spot as other considerations will allow. Option B. The film should be as far as possible from the object being radiographed. Option C. The distance between the anode and the material examined should always be as great as possible. Option D. All three of the above are correct. The correct answer is option A. The X-rays should proceed from as large a focal spot as other considerations will allow. The explanation for the given correct answer is that increasing the distance between the anode and the material being examined in radiography helps to reduce image distortion and improve image quality. This is because the further the distance, the less divergence of the X-ray beam, resulting in sharper and more accurate images. Additionally, increasing the distance also helps to reduce magnification and decrease the amount of scatter radiation reaching the film, further enhancing image clarity. Therefore, it is recommended to maximize the distance between the anode and the material being examined in order to achieve optimal radiographic results. Question 144. A distorted image on the radiograph can be caused when the specimen is not parallel with the film. Option A, true. Option B, false. The correct answer is option false. Distortion is due to the specimen not being perpendicular. Question 145. L1 If the SNTTC1A doc is to be used as a recommended guideline, the /written practice / must be submitted to ASNT for approval. Option A, true. Option B, false. The correct answer is option false. ASNT provides a service to the industry by providing LVL3 exams in the basic and method areas. The specific exam is still the responsibility of the employer, last step in the path of certifying a LVL3. Question 146. Increasing the activity of an isotope source will increase the energy of the individual rays. Option A, true. Option B, false. The correct answer is option false. Regardless of Curie strength, activity, / size of an isotope, the energy of individual rays remains the same. Question 147. When manually processing films, the purpose for sharply taping hangers 2 or 3 times after the films have been lowered in the developer is to: Option A, disperse unexposed silver grains on the film surface. Option B, prevent frilling. Option C, dislodge any air bubbles clinging to the emulsion. Option D, all of the above. The correct answer is option A, disperse unexposed silver grains on the film surface. When films are manually processed, air bubbles can sometimes get trapped between the film and the developer solution. These air bubbles can cause uneven development and result in areas of the film not being properly processed. By sharply tapping the hangers 2 or 3 times after the films have been lowered into the developer, any air bubbles clinging to the emulsion can be dislodged. This ensures that the film is in full contact with the developer solution and allows for more consistent and accurate processing. Question 148. When producing radiographs, if the kilovoltage is increased, Option A, the subject contrast decreases. Option B, the film contrast decreases. Option C, the subject contrast increases. Option D, the film contrast increases. The correct answer is option A, the subject contrast decreases. When producing radiographs, increasing the kilovoltage leads to the ionization of more atoms in the X-ray tube, resulting in a higher energy X-ray beam. This higher energy beam can penetrate through the subject more easily, causing less absorption and scattering of the X-rays. As a result, the subject contrast decreases, meaning there is less differentiation between the different tissues or structures in the radiograph. Therefore, the given answer that the subject contrast decreases is correct. Question 149. L1 To comply with the guidelines of SNTTC-1A, all 3 levels of technicians must take a/general, /practical, / specific / test if examinations are used to determine certification. Of Option A, true. Option B, false. The correct answer is option false. SNTTC-1A recommends that NDT LVL3 personnel be examined in the following areas: A, basic; B, a method; C, specific. Question 150. Photons are tiny particles of matter traveling at the speed of light. Option A, true. Option B, false. The correct answer is option false. X-rays are not bits of matter. X-rays, photons, equals little pockets of energy moving at the speed of light.